Hello everybody, welcome into another lesson. So today we are going to talk about dilations and shrinks. We're going to talk about transformations by dilating and shrinking shapes on the coordinate plane. And again, for simplicity's sake, we're going to do this with triangles again today. We could do it with quadrilaterals or other polygons or any shape, but triangles are probably the easiest to work with. So, the past two lessons between doing shifts and reflections, every time you've done the transformations, you've gotten a congruent triangle to the original. In dilations or shrinking of them, you don't get congruent triangles, you'll get similar triangles because each of the sides will be proportionate to each other. They'll have the same ratio for the length of the sides between the two triangles, but they won't be congruent when you dilate or shrink them. So often when you dilate or shrink, you're going to take each of the coordinates of this triangle, you're going to multiply them by a number called a scale factor. If that scale factor is greater than 1, it's a dilation. It makes it bigger. In a few moments, we'll get to if the scale factor is less than 1, it's a shrink. And if it's equal to 1, we're not even going to spend time on that, because if it's equal to 1, you're just retracing the same shape. That would make no sense. Now, in other courses, you can have a negative scale factor. That only not indicates a dilation or a shrink, it also indicates a reflection, too. But in this course, we're going to stick only with positive scale factors. So, the first one here, they want you to dilate triangle ABC by a scale factor of 3. So, before we do any dilations, let's list the coordinates of the original triangle. So, A, the coordinate is 2, 2. That's the original coordinate of A. B is -2, -2. And C is located at 3, -3. Okay, so yes, we have A at 2, 2, B at -2, -2, and C at 3, -3. Whenever you dilate, whatever scale factor you have, you take your coordinates, you multiply it by that scale factor. So let's start with 2, 2. We'll take 3 times our coordinates 2, 2. You just multiply that by each of the coordinates. You would get A prime. Again, the transformation of that coordinate will be prime, just like it was with shifting or reflecting. The transformed coordinate would be A prime. So 3 times 2 for the x is 6. 3 times 2 for the y, that's also 6. So A prime will be at 6, 6. So 3, 4, 5, 6. 2, 4, 5, 6. Alright, that would be A prime right here, would be at 6, 6. Now let's deal with B. You're going to take that scale factor of 3 times your coordinates for B, so 3 times -2, -2, which means that B prime, if you do 3 times -2, you'll get -6. If you do 3 times -2 for y, you'll get that coordinate also being -6. So B prime is at -6, -6. So 5, 6... right about there. That would be B prime. Let's go ahead and connect A prime and B prime. There's A prime and B prime. Now let's deal with C. You'll just take 3 times that coordinate of 3, -3, and you would get C prime would have the coordinate, if you do 3 times the x coordinate of 3, you'll get 9. If you do 3 times the y coordinate of -3, you get -9. So C prime is 9, negative 9. 3, 4, 5, 6, 7, 8, 9. 3. 9. Right about there. That would be C prime. Alright, then you just take it and connect it. And you have your dilated triangle of A prime, B prime, C prime. It is 3 times bigger than the original. And it is perfectly normal to have... Sorry, that's my dog. It is perfectly normal to have your original triangle inside of the big triangle. That is perfectly normal. It'll be centered all around the smaller triangle. So we have a dilated triangle of A prime, B prime, C prime. So all you're doing is taking your original coordinates, multiplying it by that scale factor, and you got your results. And you just connect them like you would with any other shape. Connect your dots, and you got the shape you desire. Alright. Let's do one more for dilation, then we'll get into shrinking. We'll do that next. So let me draw my nice coordinate plane again here. Just gotta draw sufficient points on the coordinate plane. Alright, let's see, we'll have negative 2, 0 will be point A. That'll be point A. 4, 5, 6, 7, 8. Alright. 0, 3 will be B. And then 3, 0 will be C. Alright, so we have triangle ABC centered right on the axis here. So this time we are going to dilate this by a different scale factor. We'll dilate this by a scale factor of 2. So we're going to dilate this triangle by a scale factor of 2. So in other words, we're going to make this triangle twice as big as it is now. So once again, what you do to dilate, you start out by finding the coordinates of your original shape, the original triangle. A is at negative 2, 0. Alright. B is at 0, 3. And C is located at 3, 0. So now we've listed our original coordinates. In order to make the dilation, we got to take these coordinates and multiply it by that scale factor of 2 that we have. So let's start with coordinate A. We'll take 2 times the coordinate negative 2, 0. Well, A prime is going to be 2 times the x-coordinate of negative 2, that's negative 4. 2 times the y-coordinate of 0, well, that's just 0. So A prime is negative 4, 0, which would be located right there. That would be A prime. Alright, now let's do it to the B coordinate. We'll take 2 times the coordinate of 0, 3. So B prime is going to be, for the x coordinate, 2 times 0, that's still 0. 2 times the y coordinate of 3, that's just going to be 6. So B prime is located at 0, 6. 6. All right. That would be B prime right over here. So let's go ahead and make the connection. And then, of course, last but not least, let's multiply the C coordinate by 2. We'll take 2 times the coordinate of 3, 0. Well, that means C prime for your x coordinate, 2 times 3, that's going to be 6. 2 times 0 for your y coordinate, that's 0. So C prime is located at 6, 0, which would be right here. That would be your C prime. And then the triangles connect here. So you got triangle A prime, B prime, C prime. You have the smaller triangle inside of the dilated triangle, which is very normal. Again, that's a very normal thing to have happen. And that's your end result, is you get this triangle A prime, B prime, C prime. And it actually looks like some of the sides overlap a bit from the original triangle to the dilated triangle. That's also normal. So that's what a dilation looks like, just makes it bigger. Now let's talk about some shrinking here. Let's do some shrinking. So dilations have been if your scale factor is greater than 1. A shrink, on the other hand, a shrink is going to be if your scale factor is less than 1. So this time, let's change that sign around. Let's make it less than 1. So if your scale factor is less than 1, you have a shrink. And it may look something like your problem. They'll still, for a shrink, they'll largely say dilate the triangle, but by scale factor, for example, of something like 1/3. Because that's less than 1. 1/3 is less than 1. You're dilating it by scale factor, it's less than 1. So let's draw our nice coordinate plane again here. All right, let's do four, 5, 6, 8, 9, 10. Again, I'm not exactly Bob Ross. I'm not the best at drawing these, but I sure do the best I can. Math is my gifting, not art so much. But when you get to geometry, well, it tends to overlap with art a bit. I never was very gifted in the art room. So hats off to those of you who are good at art. I don't know how you do it. That's very good that you are gifted in it. But anyway, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we have right here, this will be point A. We'll make 0, 0 point B. We'll go 9, 6 will be C. This will be C. So we have we have here, we have triangle ABC. We want to dilate this by a scale factor of 1/3. Well, since the scale factor is less than 1, being 1/3, we're actually shrinking it. Just like you would with a dilation, first thing you want to do, list your original coordinates. So A can be found at -9, 6. B can be found at the origin at 0, 0, right there at the origin. And C can be found at +9, 6. Alright, well now we have listed our coordinates of the original triangle ABC. We want to do the dilation, or in this case the shrink, since the scale factor is less than 1. You're just going to take that scale factor of 1/3, you're going to do the multiplication to each coordinate. So we'll start with coordinate A. We'll take 1/3 times -9, 6. So A prime, for the actual of 1/3 times -9, that'd be -3. Then for the y of 1/3 times 6, that'd be +2. So A prime can be found at -3, +2. Looks like it stays connected here. Now let's do it again for the B coordinate. You'll do 1/3 times the coordinate of 0, 0. Well, this will be easy. B prime, let's see, 1/3 times the x coordinate is 0. That's just 0. 1/3 times the y coordinate is 0. Also 0. So B prime is still at the origin. So we got A prime here. We have B prime here. So B and B prime share the same coordinate at 0, 0. But we need to deal with C. Again, do 1/3 of your C coordinate, which would be 9, 6. So C prime, you're going to have 1/3 times your x coordinate of 9. That'd be 3. Then you'll have 1/3 times your y coordinate of 6. That'd be 2. So C prime is located at 3, 2. Be right there. So the points actually rest on the original triangle. And here we have our shrunk triangle A prime, B prime, C prime right here. And it actually coincides with the original triangle ABC. You can actually have shrinks that work that way, where it coincides partly with the original. But A prime, B prime, C prime only goes to here as opposed to the whole big thing. But shrinks work really the same as dilations, as we see. And I'll do one more example here. Do one more example with a shrink, and then we'll be done with the lesson. All right. We'll make this scale factor 1/2. I'll make this scale factor be 1/2. So let's see here. We made the last triangle to be 1/3 of the size of the original triangle. We'll make this next one be half the size of the original triangle. Alright, we just draw ample points here. Almost done. Just got to draw these out. Alright, what am I going to do here? we'll go 2, 6. That'll be A. We'll go 2, -4. That'll be B. And then 3, 4. 6, 2. That'll be C. Alright, so we have, again, triangle ABC. We're going to take that, we're going to dilate this by a factor of 1/2, which means we're actually going to shrink it to half of its size. So first, before we do any transformations, let's list the original coordinates. We'll have A has the coordinates 2, 6. A has the coordinate 2, 6. B has the coordinate 2, -4. And C has the coordinate 6, 2. Alright, so we got our original coordinates. Well, we need to go ahead and multiply the original coordinates by 1/2 in order to get our transformed triangle ABC. So let's take the first coordinate, 2, 6. We'll multiply that by 1/2. So that means your A prime for your X coordinate will have half of 2. That'd be 1. Half of your Y coordinate 6. That'd be 3. So A prime is located at 1, 3. We will call that A prime. So now let's do the same to B. We'll take 1/2, we'll multiply it by the coordinates 2, -4. So that means B prime for your X coordinate, you're going to have half of 2. Well, that'd be 1. For your Y, half of -4, that'd be -2. So B prime is at 1, -2. There's your B prime. Okay. Last but not least, we got to do it to C. So you'll take 1/2 of your C coordinate, which would be that coordinate 6, 2. So that means for C prime, you're going to have half of your X coordinate of 6. That'd be 3. For half of your Y coordinate of 2, that'd be 1. So C prime is located at 3, 1, which would be right here. That'll be C prime. Let's go ahead and connect the points. And you see right beside, and actually partly inside of triangle ABC, you have the triangle A prime, B prime, C prime. Sometimes that's normal to have a little bit of it overlap inside of the other triangle. But you see, that's what a triangle half the size of the original looks like. We got that all by multiplying each of the coordinates by a scale factor of 1/2, and we got the new triangle A prime, B prime, C prime. So whether it's a shrink or dilation, you're going to take your scale factor, you're going to multiply your coordinates by that scale factor, and then you just connect the dots of your new transformed coordinates and you'll get that shape, whether it's a dilation or a scale factor, a dilation rather, or a shrink. Again, it's a dilation if your scale factor is greater than 1. It's a shrink if your scale factor is less than 1. So, and if it were equal to 1, it'd be pointless because you'd just be retracing the same shape. So that's going to do it for this lesson. The next lesson we will deal with quadrilaterals and the different types of quadrilaterals. So I hope everybody has a good day. Take care.